of CFL by empty stack or final state. So up till now, whatever problems we have solved, that is all using the CFL acceptance by the empty stack. Okay. So if pictorially or if this question is asked, then how you should answer is written. So the answer is for this question is, very first you have to write down acceptance of CFL by empty stack as the acceptance of an input string by empty stack is a common way of implementation, and that's why we have used in all earlier problem. We are always checking whether the stack is empty after reading whole string. If stack is empty, we are saying it is acceptance. But if the stack is not empty, then we are saying it is not acceptable. Okay. So how it is represented? A string W is said to be accepted by a PDA if Q0 WZ0 after multiple steps reaching to a ID which is represented by P empty empty, where this P is indicating a state which we are not nominating it as a final or anything. It is just a any state, okay, normal state. So where P is any state in Q, okay, empty and empty is indicating that your stack is, so this is what W, instead of W it is written empty. That means your string is over, your no string is remaining to be checked. And Z0 is also empty. This is indicating your bottom of the stack is nothing. It is totally, stack is totally empty. If this situation arises, then we are saying that the string is acceptable. So we have seen one example in which we have solved the problem of language A dash to N, B dash to N, where N is greater than 0, right? So for this is a transition graph of a PDA, which is representing a PDA. This is representing a PDA. So in this, we are having initial state, and like this, if you are having, so initially when A is read, your stack is empty, you are pushing A, so stack content will become AZ0. In next turn, when suppose it is A, B, B, so in next turn again you are reading, so it will be following this path. So already top of the stack is A and we are reading A, so the stack content will become AA. Next you are reading B, so it is moving to Q1 state and top of the stack is A, then you are doing nothing, that means pop operation you are doing. Now after popping, okay, you are here, if you are again reading B, you are popping, so again it is represented like this, so it will be a continuous process. After this we are having here blank, end of the string. So if at Q1 state you are getting a empty string, that means nothing is to be checked, and your top of the stack is also Z0. So what you are doing? You are doing popping operation, okay, and that popping operation will reach to, this situation will take you to the state P. So here the state reached is P, which is not nominated as a final or non-final. If you can see, no circle, double circle is indicated. But here we can see that this empty, this one, this empty is indicating your stack is now empty. So this is pop, and after popping, your stack has become the empty, and hence we will say that this string is acceptable. Okay, so in this way you have to explain this point. Second is, if you have been asked that how you will be representing the acceptance by a final state, so note it down. So a string W is said to be accepted by a PDA if Q0, comma W, comma Z0 on multiple transitions or multiple steps reaches to a ID which is denoted by this. Okay, so we are saying that we are accepting the string with the final state when your P is a member of F final state, which is designated as set of final state. So capital F is indicating set of final state, and gamma is any stack string, no matter, okay, whether it is empty or not. We are not bothering about the stack to be empty or non-empty. We are only bothered about whether this P is final state or not. Okay. So in this way, we are checking. So this means that upon reading string W, if PDA transit to final state, then W is set to be accepted by PDA. And what diagram you will draw in this case? You'll be drawing a diagram which I have already shown you in the earlier discussion. So once again I am drawing it. So your figure will be same. Only difference will be you have to nominate the string, state P as a final state. So draw it quickly because we have to discuss the later part, which is again very conceptual. So Z0 empty, and now this P is nominated as the final state. Okay. Now luckily in this case we are reaching to a state P which is final state, as well as our stack is empty, but we are not bothered about whether the stack is empty or not. Okay. So in this way you can represent the state transition diagram. So it is a state transition diagram for PDA accepting A raised to n, B raised to n by final state. Okay, so I hope this is clear to you. So for 2 marks or 4 marks, you will be getting this question.